Welcome to an introduction to systems thinking. This lecture was developed by a team of people who are also working on a lot of other systems thinking teaching modules for the design educator. My name is Eric Benson, and I'll be one of the speakers today. I'm an associate professor of graphic design at the University of Illinois at Urbana-Champaign. You can follow me on Instagram at Fresh Press Paper and see my work at renourish.org.
And my name is Michelle Fehler. You can follow me at Instagram at Nature Factor, and my website is Nature Factor. I'm a clinical assistant professor at Arizona State University.
Before we jump into the lecture, we would like to begin today by recognizing and acknowledging that Champaign, Illinois, where I live, is the ancestral homes of the Peoria, Kaskaskia, Piankashaw, Way, Miami, Mascoutin, Ottawa, Sauk, Meskwaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. Where Michelle lives, the ancestral lands of the Acamel Odam and the Peepash. These lands were the traditional territory of these Native Americans prior to their forced removal and genocide. These lands continue to carry the stories of these nations and their struggles for survival and identity today. The knowledge that the Native nations have given us is instrumental in designing in harmony with nature.
Thank you, Eric. So systems thinking is an approach to look at wicked problems. And if you've never heard the term wicked problems, these are really those challenges that we face as a species that cannot be solved with just one solution. They're very deeply rooted in multiple different audiences and situations and behaviors, and they're connected to each other, and one might cause another. And so looking at wicked problems is not an easy thing. Trying to solve wicked problems is not an easy thing. And therefore, systems thinking can help us to maybe reduce the amount of poverty or reduce how many people are dealing with hunger. And even things like traffic jams that you might encounter are considered wicked problems that we can solve with systems thinking. So some of these problems have the characteristics that they're not ever going to be really solved completely. They're not going to go away necessarily, but we can maybe shift things and we can maybe reduce some of those sufferings. Every wicked problem is very unique. There's always multiple stakeholders involved, and they're definitely connected to others. And one way to explore these is through systems thinking. So a system is actually a collection of things, such as people or cells or molecules or products that are interconnected in such a way that they produce their own pattern of behavior over time. So you could see anything that has different compartments together and makes up a greater whole is a system. Your lung is a system. A city is a system. Something that you build with Lego is a system. Your classes that you're taking is a system. So anything that has multiple components, has some kind of behavior and deals with the factor of time is considered a systems problem. And so we have a quote on the screen from Robin Wall Kimmerer, who's an ecologist, and she's an indigenous writer. And she really puts it beautifully where she says that the breath of plants gives life to animals, and the breath of animals gives life to plants. And my breath is your breath is mine. It's the great poem of giving and taking, of reciprocity that animates the world. And what we want you to get out from this poem is that we realize through systems thinking that everything is absolutely connected to everything.
Those are great definitions. They're how we frame our work and how we use systems in our design work. At a very basic level, though, a system is just a collection of interrelated or interdependent parts which form a unified whole. these parts always interact. A great example, maybe if you remember back to when you were a kid in elementary school, your teachers in your science class taught you about the food chain. The food chain is a great example of a system where each animal and plant rely on one another for survival. If you remove any one of these different parts of this system, the whole system is going to be affected and potentially be hurt. If you add more into the system, it'll affect everything else in the system as well. Hopefully you can see here that with this diagram that everything here is interconnected and everything can be impacted by a small change to something else.
So, looking closer at the anatomy of a system, we have elements, which are oftentimes the most visible or tangible components. In the example that Eric was just talking about, the acorn, the squirrel, the tree, the air, the soil, those are all of the elements of a system. And then we have the interconnections between those elements where we can see information or resources flowing from one element to another. And that's what makes up the connection between the different elements. And in human systems, it is oftentimes elements that we cannot see necessarily. So just a law or a policy can also be the interconnection between two elements that connects them. And then we always have a purpose in a system. So every system exists because there is a reason why it exists. And what is it trying to achieve? Is it trying to solve the problem of people going to work? Is that what's creating the system of traffic jam? Or is the goal of your lung, which is a system, is to bring oxygen to your body? So the purpose of a system is always very important to consider as well. And then we have a function, the ultimate outcome of what is happening. So the outcome of your lung as a system is that your body can live because it has the necessary molecules of oxygen. And so we have a purpose of why it exists, and then we have an ultimate outcome, and that is what it's doing, the system.
What else is in a system? A stock. What's a stock? Well, it's something you can see, something you can feel, count, or measure. For example, potentially in a system of the lumber industry, trees are the stock, right? You can see how many trees there are. You can feel the bark of the tree. You can count how many trees. You can measure the circumference of the tree. The other thing that's in a system is the flow. So what are the additions or the subtractions to a system? Moving in and out of inside that system is the flow. So I mentioned the forest. So here's a visual of the stock and flows of a forest. So you can see there in the middle, the stock is how many trees are in that forest. The flow goes from left to right. The inflow, which would be what's adding into that stock or the forest. So the inflow here would be new tree growth. The outflow on the right side would be logging, for instance, or a tree dying. So what's taken out of that system, that if it's more is taken out than what's going in, you have an unsustainable system. And hopefully the goal of a sustainable system is to make sure that what's going in is equal to what's going out. Everything is connected. I think that's the biggest part of this lecture today that we want you to take away from, is that everything in the world is connected. This John Muir quote, I think, is one that has been used quite often and is still quite relevant to the conversation. When we try to pick out anything by itself, we find that it's bound fast by 1,000 invisible cords that cannot be broken to everything in the universe.
So why use systems thinking in design? Systems thinking can help to understand the bigger picture, as well as the details of what makes up the bigger picture. Systems thinking can help visualize the relationships and connections between the elements and the factors. We can also locate the best areas to intervene. Those are called leverage points. So where in the system should you come up with a solution that then has the desired outcome in the system as a whole? And then it also makes it easier to actually balance long and short-term solutions in a way that makes them regenerative and sustainable, because we're approaching the problem through the idea of everything is connected. And so we have some principles of complex systems that we want to respect as we're working with systems thinking. And the first one is that we need to look for interconnections. Nothing is in its vacuum. So the story that you will watch as part of the homework is that it talks about the entire elephant rather than just one element. If you explore one part of an elephant, you might not know that the whole thing together makes up an elephant. And so looking at the interconnections is super important. And then we also want to expand it through time and space. So we don't want to look at it just in our own scale as a human. We can explode it out and we can go into details, which is also another video by the Eames that we're posting about. And then we have to stay humble. We have to stay curious, and we have to keep asking questions while also honoring information that we find and not trying to control what we find, but really being humble enough to discover the truth behind what the system needs and what the system is. And then we as humans or as problem solvers, we should blame the system and not the individual players. It is not the individual person that is homeless that is the problem. It's the system in which this person has become homeless that is the problem that we have to solve. So we want to make the system responsible, and we want to find leverage points in the system to solve for the person that would end up homeless. And then we have to also challenge underlying mindsets that are ingrained in our society, and we have to be aware of those mindsets in order to design with or against them to change the paradigm. And the most important principle of designing with systems is to have compassion for others and to understand where people might be situated within a system and what kind of complexities they're dealing with, and then designing with them or for them in our mind.
Well, thank you for joining us for this brief lecture today on systems thinking. It's definitely just an introduction, and we hope you enjoyed it or are interested in learning more. Part of our collaborative is that we are doing more around systems thinking, and you can learn more about what we're doing at renourish.org/systems-thinking-cluster.